Hey, we're going to go through a problem here. It's number 16. It says find the surface area of the function y equals the square root of x plus 1 rotated around the x-axis. So we know what the square root function looks like. X plus 1 just kind of moves it a little bit. We're going to go around the x-axis from x equals 1 to x equals 5. So first of all, the surface area formula is a combination of circumference and hypotenuse, the Pythagorean theorem, but it's 2 pi times the integral from a to b of f of x times the square root of 1 plus f prime squared dx. So first, f of x was our original function, which we can write as x plus 1 quantity to the 1/2. That's the square root function. We take the derivative using the chain rule, and then we square the derivative, and that gives us 1 over 4 times x plus 1. Okay, so I'm going to drop those into my formulas here. I'll have 2 pi times the integral from 1 to 5 of x plus 1 to the 1/2 times the square root of 1 plus the fraction 1 over 4 times x plus 1 dx. Now I've got 1 plus a fraction under the square root, so I'm going to make a common denominator, and that common denominator would be 4 times x plus 1. And when I do that and add everything together under the under the root, I'll have 2 pi times the integral from 1 to 5 of x plus 1 to the 1/2 times the square root of the fraction 4x plus 5 over 4 times x plus 1. And what I can do here is, because I have a fraction under the square root, I can split that fraction into a numerator and denominator. So I can take the square root of the top and the square root of the bottom separately. And I went ahead and wrote them with to the 1/2 instead of using the square root symbol. And when I did that, I have several things that will cancel out. I have a 2 in front of the integral, and I have a 2 that comes from taking the square root of 4 from the denominator. Those cancel out. And I have a x plus 1 to the 1/2 out front. That was the original function. And then the denominator of the function, I had x plus 1, and I'm taking the square root of that, so they cancel out. So if I cancel out what I have there, I can get down to the integral of pi from 1 to 5 times the square root of 4x plus 5. And that's fairly simple to integrate with the u substitution, letting the u be 4x plus 5. But after the u substitution and the integration, I get 1/6 pi times the quantity 4x plus 5 to the 3/2. That's my integration. And that's going to be evaluated from 1 to 5. Okay, so I'm going to plug in the 5, I'm going to plug in the 1, and when I finish plugging them in and subtracting, I get 49 pi over 3, and that's the surface area created here.